Actually have who's recently replied to his own message.
Alright, this is the laws of electromagnetic inductions. A little quick review. First, it all began, the revolutions began with somebody named Ørsted. You still remember? Yeah, Hans Christian Ørsted. Where is he? Where is she from?
Norway.
No, Denmark. Denmark, okay? What is his famous inventions? Do you still remember?
Ørsted's
Something that is actually happened accidental. He has a compass here.
Oh.
You still remember? He actually wants to show that current flows in a conductor creating heat. You still remember that? Is it on?
Yeah.
Yes.
Should be.
Creating heat. So, steady current. This is the experiment from Ørsted. Experiment Ørsted. A very quick review, and then we compare it with the electromagnetic inductions. Experiment by Ørsted. Which is in main statement says a steady current, which is from the battery. It is indeed historically from the battery that pass through a conductor, which is this electrical coil. A steady current that pass through a steady current that passes through an electrical conductor such as this spring coil, such as straight current conductor, always produces, remember? Produces blank. Do you still remember? A steady current passing through a current carrying conductor produces magnetic field. Thank you. Produces a magnetic field. A magnetic field. In fact, it's a steady magnetic field. A steady magnetic field. That's the most important inventions in just 300 years ago. That revolutionized the scientists, because they are now desire to know more about electricity. And then, before we go here, that's exactly what I touched, what I talked about. And then Faraday had an idea. Would it be possible to have the opposite? What does it mean, the opposite? The opposite means like this. When you finish writing, yes, when you finish writing, then I will tell you what Faraday had been thinking about. Can you guess, when it comes in respect to electromagnetic inductions, and you knew it already, what could have Faraday been thinking? He was thinking about the opposite. Would it be possible to have the reverse process? What does it mean, the reverse process? Here, what is the real, yes?
I'm guessing the opposite would be a steady magnetic field creating or producing a steady current?
Yes. Amazing. That has been his thought. Can you write that? He's been thinking about the opposite. Can the opposite be true? Can the opposite be true? And you have heard what Mindy has said. Here with Ørsted, steady current produces steady magnetic field. What about the opposite? The opposite, then you just flip the words, correct? So steady magnetic field. Can a steady magnetic field produces a steady current? So this is the issue that I am trying to trigger on you, and certainly you know the answer. The answer is
Yes.
the answer is yes in this means. So what about you, brother? Yes. What about you, Kyra? Sure. What about you, sister? What about you, Jasmine? Sure. The answer is unfortunately
Wrong.
no.
Whoa.
And that's a big surprise for him. Not only a big surprise
Big.
to Paradise. Because he's expecting the same. If this it produces this, what about the others? Like our economy produces big money, and we want to create big money by producing infrastructures. And we hope by having the infrastructures like streets, bridges, tollway, and so on, it can produce even higher economy. Correct? Does it make sense to you?
No.
No, it doesn't. It never makes sense to you when I talk about economy, right? I know. But that's what he expected. The answer is no.
No.
But listen, as he tried to put, like, let's say here, a rectangular coil and connect it to the ampere meter. He connects it to the ampere meter or any kind of current, voltmeter and so on. He expects to have this steady current magnetic field, and this magnetic field hopefully can create a steady current. The answer is no, because it is indeed no. Nothing happens. But something weird happened. And he discovers it accidentally again. You know what happened? I will tell you after you finish writing. Sesudah pariwara berikut ini. After the advertisement. Because it's still writing, everyone.
After the
So I cannot
advert.
say
Say
anything.
can the opposite.
Can the opposite be true?
Can the opposite be true? Can steady magnetic field produces a steady current? Right? And the good thing about your answer is, because you answered wrong, which also Faraday could have thinking, no way, it should be producing, but the answer is no. This is what happened. He creates a steady current, creating magnetic field. Magnetic field influences this rectangular coil with the hope that it produces current again, correct? But cannot at all. Until he suddenly realized something when, listen to me, when he opened the switch, suddenly he saw something. When he opened the switch, he saw something. When he closed the switch again, he sees something again.
Whoa.
Mentioned here. Apparently, induced EMF has been taking place when the switch is on, or is being put on, or being cut. Understand?
Yes.
In German, we have to be very careful using the words. Der Schalter wird geschlossen. Und plötzlich kommt der Strom. Nicht, wenn der Schalter geschlossen ist, kommt der Strom. You understand? Everyone? Can I say again? Can I repeat again? Yeah?
Yeah.
I'm going to write it here.
Ah, okay.
Geschlossen werden and geschlossen
Not
is.
when
Is closed and is being closed.
Yeah.
Understand? So you have to be very careful in the exam when you use the word is closed versus is being closed. And then the other one is open versus is being open. Alright? Do you see the difference? Wird geschlossen, ist geschlossen. Unterschiedlich? Unterschiedlich,
Yeah.
mein brother Finzer. Is open, is being open. So when the switch is closed or is open, when the city current flows or not at all, no current has been induced here and no EMF has been induced here. Is that clear, everyone? Yeah. But when he tried to quit his experiment and open the switch, so the switch is now being opened by Mr. Faraday. Suddenly he observed current. He observed EMF.
EMF.
Do you understand? The same thing also true. When the switch is open, nothing happens. When the switch is being open, happens. When the switch is closed, nothing happens. When the switch is being closed, something happens.
Repeat that.
Hmm?
Could you repeat that?
Yes, I can. Can you repeat that? Brother? Okay, can you help?
So when the switch is opened, nothing happens. But when the switch is being opened, then something happens.
Yes, something happens, man. The current is measured, the current is observed.
Yeah.
So there's an electrical current, induced current, and there is an induced EMF. Understand?
Yeah.
Being. So wenn der Schalter geschlossen ist, plötzlich hier gibt es induzierte Current, induzierte Strom und induzierte Spannung. Wenn der Schalter geschlossen oder wird geöffnet, induced EMF. Wenn der Schalter geschlossen ist oder geöffnet ist, nichts passiert. Understand, everyone? So the key for our electromagnetic induction is not this one, but the key is do you still remember? The key is basically by electromagnetic inductions. The key by the electromagnetic induction is
That's the movement.
movement. Movement of who?
Either the magnet or the coil.
Yes, either the magnet or the movement of current. So basically, you move the magnet, varying magnetic field, or you create unsteady, not steady current, which create a changing magnetic field. Understand? When you open or close the switch, basically you change the magnetic field. The magnetic field is not in a steady state. Understand? Varying magnetic field. You still remember? Varying magnetic flux, varying magnetic field. And you still remember that's the keywords my students always keeps in mind when they don't understand at all. In IGCSE in A level, they try to keep up with this word, right? You still remember? With the hope that they still can get point with these most important keywords in electromagnetic inductions, which is varying magnetic field, varying magnetic flux, variable magnetic flux. Understand, everyone? So now repeat: electromagnetic field, electromagnetic inductions, I mean, is just a creation of electricity due to creations of electromagnetic energy. The creation the creations of induced EMF as well as induced current by induced EMF or induced current by varying magnetic flux or field. If you forget the word flux, it's okay. Field. Yes.
So could you turn off the beamer or put it down? Oh, okay.
Oh yeah, because of this. Yes. The creations of induced EMF, induced current by ferromagnetic field or flux. One of them, Ninja said, hey, move the magnet in and out, move it in respect to the conductor, correct? Yeah. And now, you see also, you can also create a very magnetic field not only by moving or motions of the magnets, you can also create electromagnets, which is always changing by using not the CD current but unsteady current, changing current as well. Do you understand, everyone? Yes.
Du kannst einfach, geh einfach, ja, nee, es passt. Geh einfach darüber, setz dich hin, mach weiter und ich schraub's so.
Ach so, jetzt verstehe ich. How exactly, man? How do you create ferromagnetic flux?
Oh, could you put it down a bit, please? The light from it.
Yeah. How do you create ferromagnetic flux again? First, moving magnet in relations to the coil, to the conductor, right? In respect to the coil, relative to the coil, relative to the conductor. First. Second, today, using alternating current, correct? Changing current, using not steady current. The opposite of steady current is alternating current. Okay, alternating current. So not DC, not direct current, but AC. Be careful not to write in the exam AC/DC. You know AC/DC, right? The metal band. It doesn't help you. Always remember, only the AC is important now in this chapter. Understand? Using alternating current, and you just say it also, using relative motions. You can either move the coil, move the conductor in respect to the magnet. Magnet stays still. Conductor move near away to the magnet, or the opposite. You create relative motions between them. Correct? And after we studied this, loads of electromagnetic inductions, and I give you the full versions of the induced EMF load. You know that you can also change the area of I don't have top case now of the conductor. The area of the conductor. The area of the conductor. Sir, so hard lah, remembering all the theory here. No, not at all. Just remember the laws. You still remember? BDA times ADB
Times or plus?
plus A times DB. I mean, I mean,
okay.
do I say something else?
Times.
I say times.
Yeah.
Okay. Sorry, brother. Sorry, sister.
Divided by
Over dt is equals to equals to d
D.
v d
Oh,
t, correct?
induced.
And if I put the number of coils here, this remember?
EMF.
I put, yes, do I make 6?
No, 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 no. Yeah.
Right? Here, dB dt or dV dt, if I put here, then I create EMF, induced current, induced voltage, induced EMF. Wait a minute, what do you mean? I can remember it easily. Look carefully, look carefully. Changing the area of the conductor, changing the area of the rectangular coil, changing the area of my cable is basically included in this formula. Am I right? dA over dt. Rate of change of area in time. Rate of change of area in time. Correct? A dt.
Yeah.
So A dA dt is changing the area. dA delta means change. Delta A delta T, delta A over delta T, changing of area in time. The rate of change of area. But then you can also create an induced EMF by changing everyone. By changing
DB.
by changing the dB/dt. What does it mean, dB/dt?
Magnetic flux over time.
Magnetic flux density. Understand?
Yeah.
So you change the magnetic field. How? Relative motion lah.
Yeah.
Understand? How? Changing the current lah. That creates the electromagnet, which is the AC alternating current. Understand?
Yeah.
Alright. So basically, it's all that. That is the formula that you should remember and inhale contain the whole things. I speak German and English at the same time. Yes? You understand?
Yeah.
Alright. And then we go. Yes, Nami?
No, it's just that I can't see.
Sorry. Sorry, my bad. Should I stop first? Maybe can you stop first? It's disturbing her.